Okay, hello and welcome back to week 2, lecture number 4 of the OpShin Pioneer Program. Previously we have explored different kinds of validators, untyped and typed, and also a very simple do nothing validator and always pass, and a very simple and slightly more complex equality check validator. And now we will look at different variations of contracts. So one of them is this gift contract that always returns none and does nothing. This contract, as you can imagine, is not really useful, but more of demonstrative purpose. There's also a burn contract, which always fails. So, as I told you, a contract can either pass, i.e. throw not an error, or throw an error. And throwing an error can happen in different ways. You can try to have an out of index access or out of bounds index access, or you can have, as we had in the untyped variant, you can have an error trying to convert values, or you can have an assertion error where you try to assert equality between two things. And this always fails validator just asserts false, means it will always fail. So yeah, that's also more demonstrative contract. Both of these were untyped, but there are also typed variants. It just doesn't matter which type they have, because they don't look at the parameters at all. Now, the 42 contract is a bit more complex, and it looks at the redeemer. As you might notice, if we only check for the redeemer, there will always be a way for a user to unlock the funds locked at this script, because this, looking at the code already, you can see, okay, I just need to construct this redeemer, and the user trying to unlock the funds has full control over the redeemer. So basically anyone can control unlocking funds from here. Note that this is also the untyped variant, and generally we would want to have this more succinct way of writing it, which uses types. Then we can also define custom data types. So this is a bit more complex. Before we just had just a pure integer as a parameter, but similar to how the scrim context is a much more complex data structure, also our redeemers and states, the datums, can have more complex data structures. So here, this is more of a toy example. Let's give this one a constructor ID. Let's see 1, and it has one field which is R, and you can see that this performs the exact same operation as previously our typed. But here we could now, for example, also add more fields, which would be a byte, for example, and then we can check also for equality there. For now, we just really construct a redeemer that has a single field, and then we access this field using .r. We get an instance of this, we access a field, and then we check for equality with the integer. And you can go ahead and try to lock funds and unlock them. Also look at how the CBOR and how the hash, how the dictionary, how the JSON representation looks for this. You will find that it looks slightly different than the pure integer, and you will find that it looks actually more similar to the unit, which has constructor ID 0 and no fields, and this has constructor ID 1 and one field. And you can try to interact with these scripts using PyCardano or the Cardano CLI. That's what we've learned this week. Yeah, I'm looking forward to present you the homework for this week, which will also give you a more hands-on experience interacting with these contracts.